We cannot control the ocean, but we can choose how we navigate the changes it brings. Sea level rise is not just a mapping problem, it is a decision problem. Coastal risk studies are expensive, slow, and fragmented across datasets, maps, and specialized models. Built with Codex and GPT 5.6, ShoreCast transforms that technical evidence into a clear, traceable coastal risk story. ShoreCast was designed and tested by a professional coastal numerical modeler. It combines established engineering methods with leading coastal modeling systems, including Delft 3D Flexible Mesh and XBeach Surfbeat, to assess flooding, wave-driven beach erosion, and shoreline change. This Build Week demonstration focuses exclusively on the Seadrift 338 case study. ShoreCast starts with the questions people actually need answered. What could flood first? When does the risk grow? Is the shoreline changing? And what evidence supports the conclusion? Technical details remain available, but the first experience is designed for a homeowner, planner, or advisor, not only for another modeler. Codex helps locate, retrieve, and organize the best available open-access coastal data from trusted sources such as NOAA, USGS, and state and local agencies. ShoreCast records where every dataset came from, then normalizes elevation, sea level scenarios, waves, shoreline change, property information, and numerical model output into consistent coordinate systems, units, and metadata. The evidence is checked and converted into traceable maps, animations, and decision-ready visualizations. For this site, ShoreCast tested 4 Stockton RUNUP sensitivities against independent Cosmos results. The 50% case produced the best overall land and backshore overlap across the complete scenario set. We therefore use it as a practical planning screen, not as proof that exactly half the theoretical RUNUP will occur. CoastSat adds 8,634 satellite observations since 1985, indicating a median 0.25 meter per year landward trend. Cosmos Coast adds the future check. Its 2100 scenarios also shift landward across the beach in front of Seadrift 338. Observations and projections point in the same direction. Delft 3D Flexible Mesh with native XBeach Surfbeat uses independently validated flow and wave components to simulate water levels, waves, currents, and wetting and drying. The latest coupled output shown here reaches 12:30 UTC, about 3 hours before the design water level peak. New inundation develops mainly from the lagoon and inlet while the Seadrift 338 house and parcel centers remain dry. This reveals where water arrives from, not only the final flood footprint. During Build Week, Codex and GPT 5.6 helped turn this scientific workflow into a reusable product. They accelerated data adapters for XBeach and DFlow FM, automated quality checks, generated consistent figures, created the Blender visualization handoff, built the owner-facing experience, wrote documentation, and tested the complete pipeline. The coastal modeler still controls the assumptions, validation, and final engineering interpretation. AI never invents or modifies the modeled flood extent. Comprehensive coastal risk assessments can take a year or more and cost hundreds of thousands of dollars. Larger regional studies can take several years and cost millions. By making recurring preparation, comparison, quality control, visualization, and reporting reusable, ShoreCast reduces duplicated professional effort, helping experts support more communities as they adapt to climate change. Every generation inherits a changing coastline, and makes decisions that shape what the next generation inherits. ShoreCast, world-class coastal science, made clearer, faster, and more accessible with Codex and GPT 5.6.